All right, 7-1, looking at systems of linear equations. So we're going to look at two different ways that you can solve a system of equation, which a system of equations is just more than one equation, then those two equations have the same variables with them. So when you solve a system of equation, there are three possibilities that you can get for solutions. They could intersect, and if they do that, they give you one solution that you can write as an ordered pair. And that's called consistent independent. The lines could be parallel, and that would mean you have no solution, or those would be called inconsistent. Or you could have that the two equations are the same line, and that's going to give you infinitely many solutions, which is called consistent dependent. Now, I wouldn't worry so much about the inconsistent and consistent names as more or less knowing that the three possibility of solutions are one, no solution, or infinitely many. There are technically three different ways that you can solve a system of equations, graphing being the third one, but we're going to focus on just substitution and elimination as our two algebraic ways to solve a system of equations. So substitution is basically you're going to take one of the two equations, you're going to solve it for either x or y, and then whatever you get for that one, you are going to substitute it or replace in the other equation what you got, or plug it in. I typically say this is a good option to use if one of your two equations, the x's or y's, do not have a coefficient in front of them, because that makes it easy for you to then solve for x or y. The second method is elimination, and this involves multiplication and or addition or subtraction to eliminate one of the variables, so that then you can get that one equation that has that one variable and you can solve it. All right, for this one to work, you have to have the same coefficient in front of your x's or your y's in your two equations. Right? They have to have the same coefficient. If those same coefficients have the same sign in front of them, like both positive or both negative, then you will subtract the two equations. If those two coefficients have different signs, meaning one is positive and one is negative, then you would add the two equations together. And you're going to see each of these as we go through and do some examples here. Starting out, our first equation here, we're going to do this with substitution. Reason being is, if you notice, this y right here does not have a coefficient in front of it. So that makes it an easy candidate for us to solve for that one. So we're going to solve this first equation for y. Right, so if I do that, I'm going to come down here and do that. I would add 2x to both sides, and I would end up getting y equals 2x plus 1,000. Then, based on what it says, now I'm going to take what it is equal to, and I'm going to substitute it in for y in that second equation. So that's going to give me 0.05x plus 0.06 times 2x plus 1,000 equals 400. And then I've got an equation that has just x's in it, and that's something that I could then solve for x. So I'm going to start that process by distributing that 0.6 or 0.06 and keep solving it from there. 0.6 times 2 gives me 0.12. 0.06 times 1,000 is 60. I'll combine my like terms together and get 0.17. Subtract 60 from both sides. Get 340. Divide by 0.17, and we get x is 2,000. Now that we know what x is equal to, now we're going to solve for y. So you're going to go back to one of the first two equations, does not matter which one, and in place of that x, you are going to put 2,000. Of these two equations, I would say that the first one would be the easier option because you're not having to deal with those decimals. So if I plug that in, that's going to be negative 2 times 2,000 plus y equals 1,000. That's going to give me a negative 4,000. I would add 4,000 to both sides and get y is 5,000. So now that I have x and y, my solution is 2,000, 5,000. And again, we write those as ordered pairs, right? Because that is technically where those two lines would intersect. Go into example number 2. These two we are going to solve using elimination. Looking at these two equations, I noticed that the x's and the y in the first equation do not have coefficients, but in order to eliminate one of the variables, they do elimination, they do have to have the same number in front of either the x's or the y's. Looking at my two options, I believe that y would be the better option to get the same coefficient in front of, because those y's have different signs. The y in the numerator, or the top one, is a negative, whereas the one in the second equation is a positive. So that means I could add these two equations together to eliminate that y variable. But in order for that to happen, it has to have the same number in front of it as the bottom equation. So that means I need to take the top equation and I need to multiply it by 2 in order to get that same coefficient. So that's going to give me 2x minus 2y equals 10. And then that bottom equation, I'm just going to slide it over underneath that first one. And like I said, because they have different signs, right, like it's a negative 2 and a positive 2, then I'm going to add these two equations together to eliminate that y. So 2x plus 3x is going to be 5x. Negative 2y plus 2y, it's going to cancel each other out. 10 plus 10 is going to be 20. Now to solve this for x, I divide by 5, and I get y is 4. Excuse me, not y, x is 4. Now that I know what x is equal to, just like the previous ones, we will plug that back into one of the original equations, and we will solve it for y. I'm going to go with that top equation, plugging in 4 for x, and then solving for y by subtracting 4 and dividing by negative 1. So we get y is negative 1. So we got 4, negative 1 as our solution. All right, the rest of the ones that we're going to look at are going to be doing applications or word problems involving systems of equations. So here the keys are: you've got to identify what your variables are going to be, set up your equations, and then you can use substitution or elimination to help you solve for those requested variables. And it says be sure to include labels with your answers, all right? Not just x and y, but actually what the problem is referencing. So first, our first one here has 2 DVDs and 3 CDs cost $78. 1 DVD and 4 CDs cost $74. What is the cost of a single DVD? So since they're asking us about the cost of a DVD, then it would make sense to me that my two variables are going to be involving my DVDs and my CDs. So I'm going to let X be my DVDs and Y be my CDs. So when I write my equations, I'm going to have 2X for 2 DVDs plus 3Y for CDs equals $78. The second one is 1 DVD, so just an X, plus 4 CDs, so 4Y equals $74. Right. For this one, you could easily do it elimination or substitution. If you chose substitution, I would say take that bottom equation and solve it for X. And then you could plug that in for X in that top equation and solve. What I'm going to personally do for this one is I'm going to do elimination. And I'm going to do that by trying to get the same coefficient in front of my X's. And that same coefficient would be a 2. And in order for me to get a 2 in front of that X, I need to multiply that second equation, the entire thing, by 2. So that's going to give me 2X plus 8Y equals 148. And then I'm going to slide that top equation over on top of it. And then looking at those X's, because they have the same sign, meaning both of them are positive 2's, that I will subtract these two equations in order to eliminate those X's. So 2X minus 2X cancels each other out. 3Y minus 8Y is negative 5Y. And 78 minus 148 is going to be negative 70. I'll divide by negative 5, and I'm going to get Y is 14. And that's $14, and that would be $14 for a single CD. To get the price of a single DVD, which is what they ultimately ask us for, I'm going to take that 14, I'm going to plug it back into either one of the original equations, and I'm going to solve it for X. I think I'm going to choose that second equation, and I'm going to plug in 14 for Y. So 14 times 4, we get 56. Subtract 56 from both sides, and we get $18 for a single DVD. Example number 4. At Starbucks, an orange mango banana blend smoothie contains 6 grams of protein and 5 grams of fiber. A banana chocolate blend smoothie contains 21 grams of protein and 6 grams of fiber. How many smoothies of each type would you have consumed 243 grams of protein and 72 grams of fiber? So this one can be a little confusing since they have information about the different types of smoothies and they have information about protein and fiber. So you're kind of thinking, well, which should be my variables? Key thing is here they ask us about this, how many of smoothies of each type. Since they're asking us about how many smoothies of each type, then that tells us that is our target for our variables, is the type of smoothies that we're talking about. So I'm going to let X be our orange mango banana blend smoothie, and Y is going to be our banana chocolate blend smoothie. As far as setting up our equations, we're going to have one equation that focuses on protein, and we're going to have one equation that focuses on fiber. So we're going to have 16 grams of protein. So that would be 16x for the orange mango, plus 21 grams of protein for the banana chocolate, so that's 21y, equals a total of 243 grams of protein. We're going to do the same thing for fiber. 5 grams of fiber, so that would be 5x for the orange mango, 6 grams So 6y for the banana chocolate blend for a total of 72 grams. Right, looking at these two equations, right, I think elimination is probably going to be a good option here. And we're going to have to get that same coefficient in front of one of those variables. When you see one like this where they all have coefficients in front of them, and it might be kind of difficult to think about how can you get the same number in front of either x's or y's. Easy solution is decide which variable you're going to eliminate, and whatever the coefficient is in one equation, you're going to multiply that by the other equation, and then whatever the coefficient was in the first equation, you're going to multiply the second one by that coefficient in the second equation. So here I think I'm going to go with trying to eliminate the x's. So in order to do that, I'm going to look at the bottom equation has a 5 in front of the x, so I'm going to multiply the top equation by 5, and then the top equation has a 16 in front, so I'm going to multiply the bottom equation by 16. This is going to allow me to get that same coefficient in front of those x's, right? Which then I would be able to, in this case, I'd have to subtract those equations again because they are both positive numbers in front of the x's, all right? And so I'm going to leave you to be able to solve the rest of that equation. All right, I kind of got you started there, but you can always go into Moodle and check your solution to see if you did it correct. All right, our last one here, Ruby's setting up, she's invested in 2 different mutual funds. She, in 2008, she lost 32% of one. That was the Fidelity Balance Fund. She also lost 50% that she invested in the Fidelity Value Fund, and her losses totaled $42,800. How much did she invest in each fund? So each fund right there tells us that our funds have to be our different variables. So we're going to have X be one of those. I'm going to let that would be the Fidelity Balanced Fund. And then I'm going to let Y be the Fidelity Value Fund. So initially, she invested in both of those funds, so X plus Y, and she invested $100,000. So X plus Y was $100,000. She lost 32%, so 0.32, from the Fidelity Balanced Fund, which was X, plus she lost 50%, so 0.50 Y, and the total losses was $42,800. I would probably say maybe do substitution for this one. Take that top equation and solve it for either X or Y, and take what you get and plug it in to that second equation to help you solve for one of the variables. Right. I'm not going to tell you which one to pick, all right, but you pick one, whether you pick X or Y. All right, you could have also done elimination. You could have tried to get the same coefficient in front of those variables, but that does mean you have to work with decimals a little bit more, which I know we're not a huge fan of. So that's why I would go the substitution route. And I've kind of told you how to get it started. I've gotten the equations to help you set those up. So I'm going to leave you with solving the rest and going into Moodle and checking the answer key to see how you did on this example as well. All right, usually the hardest part for most students is getting it set up. So hopefully seeing me set them up and kind of talk through them will help you with any questions you might come across in later assignments.